Cross-validation. Cross-validation is a technique for evaluating how well a machine learning model will perform on unseen data by splitting the dataset into multiple subsets and testing the model on each subset separately. Think of it like testing a student multiple times with different question sets instead of just one final exam. You divide your data into parts, train on some parts, test on the remaining part, then rotate which part is used for testing. This rotation ensures every piece of data gets used for both training and validation, giving you a more reliable measure of your model's true performance. In practice, a data scientist building a spam filter might use 5-fold cross-validation, splitting their email dataset into 5 equal parts. They train the model on 4 parts and test on the 5th, repeating this 5 times with each part serving as the test set once. This approach is more robust than using a single trained test split, similar to how training data is used to build models. The averaged results reveal whether the model genuinely understands spam patterns or just memorized the training examples. Cross-validation matters because it prevents overfitting and provides a realistic estimate of how your model will perform in production. It's standard practice in machine learning competitions, research papers, and industrial applications where model reliability is critical. Cross-validation.